Welcome to my Sylvestre Goodwill channel. We are going to realize an exercise about optimization with constraints. Let's have a look to the exercise. Factory manufactures two kinds of products, P1 and P2, machined in two workshops, A1 and A2. The machining times for P1 are of 3 hours in workshop A1 and 6 hours in workshop A2. For P2, the machining times are of 4 hours in workshop A1 and 3 hours in workshop A2. The weekly availability time of workshop A1 is 160 hours, and that of workshop A2 is 180 hours. The profit margin is 1,200 euros for a piece P1 and 1,000 euros for a piece P2. We can write X, the number of products P1 to produce and sell, Y, the number of products P2 to produce and sell. If you prefer, you can write X1, the number of products P1, X2, the number of products P2 to produce and sell. We are going now, in first question, to formalize the plant optimization problem. In workshop A1, we have to use 3 hours to produce one P1. So we put 3x plus we add the consumption of hours for the product P2 we need in the workshop A1, 4 hours. So we add 4y or 4x2 and 3x plus 4y is under or equal to 160 hours. We write the first inequation. Now the second inequation in the workshop A2. We need in this kind of workshop to produce one P1 the machining times for P1 is 6 hours in workshop A2. So we put 6x plus the machining time to produce P2 in the second workshop is 3 hours. So we add 3y. So the second inequation is 6x plus 3y is under or equal 180 hours. We know that x and y must be up or equal to 0 because it is impossible naturally to have negative production. We can replace by the letters x1 and x2 or if you prefer in the two equations. Now we are going to determine the economic function to maximize. One product P1 gives us net profit, a profit margin about 1,200 euros, and the second product P2 1,000 profit euros. So we write the economic function with this letter is equal to 1 1200x plus 1000y, or if you prefer 1200x1 plus 1000x2. For the third question, we are going to use the constraints polygon method to determine graphically the domain of permissible solutions. We draw the two lines about workshop A1 and workshop A2. We consider we are going to use all the capacity available in hours to be on the lines. So we are going to write the inequation in an equation. We equalize 3x1 plus 4x2 with 160. This equation, we draw the line. For example, we consider we are not going to produce x1, so x1 is equal to 0, and then we obtain 4x2 is equal to 160. So x2 is equal to 160 divided by 4. We obtain 40 there. So we put the first point A. Then we choose a second point to draw the line about the workshop A1. If we consider we are not going to produce x2, so we are the x2 equal to 0, we obtain 3x1 is equal to 160 hours. So x1 is equal to 160 hours divided by 3, and we obtain 53 approximately there, 53. We obtain a second point. We draw the first line for the workshop A1. Now we consider the constraints of the workshop A2 with the equation 6x1 plus 3x2 is equal to 180. Why is equal? Because we consider we use all the constraints. So we draw this kind of line for the workshop A2. I repeat, 6x1 plus 3x2 is equal to 180 hours. If x1 is equal to 0, we obtain 3x2 equal to 180. So x2 is equal to 180 divided by 3, we obtain 60 there. So we put another point, a third point for the beginning of the second line. Then if we consider x2 is equal to 0, we obtain 6x1 is equal to 180, so x1 is equal to 180 divided by 6, we obtain 30. We put the second point of this second line for the workshop A2. Now we see that the two lines cross there in this point. So at the right, it is impossible to produce. If you have a doubt, for example, if you consider we are going to produce 50x1, 50x1 or 53x1 and 0x2. So with this kind of production, 53x1, we have a look to the first constraints. We can multiply 3 by 53. We obtain 59 hours. So we are under the constraint A1, so it's okay for the first workshop. And now for the second workshop. For the second workshop, we multiply 6 with 53, x1, P1 to produce. So 6 multiplied by 53, we obtain 318 hours. So it's strictly impossible because the capacity of the available capacity of the second workshop is only 180 hours. So this point on the right of this zone is not possible. It's the same for 40, for example, and so on till 30. There we can now draw the admissibility zone, the polygon of constraints. We are going to choose what kind of production we are going to realize. It is possible with the point A, B, or C. Of course, the point O, 0, is not possible because we decide to produce. So it's not possible to be on 0. In the fourth question, we determine the coordinates of the vertices of the constraints polygon. For the point A, 30 and 0, B, 16 and 28, C, 0 and 40. And now, in the fifth question, we are going to calculate the profit for each point, vertex summit point of the polygon, the 3 summit or vertex point of the polygon constraints, the admissibility zone. With the point A, what is the weekly margin? We know that X1 gives us a product P1 gives us a profit margin per unit of 1,200 euros, and the second kind of products per unit 1,000 euros. So we have to multiply 30 by 120, and we add plus 0 multiplied by 1,000. We obtain naturally only 30 multiplied by 1,200 euros. We obtain 36,000 euros margin. Now for the product B, we multiply 16 by 1,200 euros. We obtain 90,200 euros, and we add 28 multiplied by 1,000. So we obtain 47,200 euros benefit. And for the point C, we only produce P2 and sell this kind of product, so we obtain 40 multiplied by 1,000 euros, we obtain 40,000 euros benefit. So the maximal benefit is 47,200 euros. It corresponds to the point B. So the optimal weekly production is 16 P1 and 28 P2. That's all for this video. I hope it was okay for you. See you soon on my Sylvestre Goodwill channel. Bye bye.